Welcome everyone. Today we will continue discussing on alpha abstraction and beta abstraction. We have seen alpha elimination and beta elimination and corresponding the reverse reaction. Today we will mainly focus on alpha abstraction and beta abstraction. As you know, the products which we are going to get by this transformation are going to be exactly same to that of alpha elimination and beta elimination. But still there are fundamental differences that can distinguish these processes. Let's try to look at these in greater detail. So the alpha abstraction. Alpha abstraction is mainly a process where you have your metal alkyl species, and in this particular case you are going to get these alpha position hydride abstraction directly by something else, which is, let's say, attached to the metal center. Here there is no association of metal hydride as such. There is no metal hydride intermediate bond formation. This is the alpha abstraction. Net result is giving you metal carbene species. If you just want to compare the alpha elimination, this is very simply, let's say you have a ligand metal complex and an alkyl intermediate. Of course, these reactions are reversible in nature, and at the end you end up getting ligand metal hydride species along with these carbene intermediate. So if you compare these two reactions, the first one versus the second one, of course the product wise it looks similar, right? Both of them forming a carbene intermediate, but in this case there is no metal hydride bond formation. Over here in alpha elimination, as you have seen, there is this metal hydride bond formation. In this particular case, this alkyl group is acting as a base. Okay, so this is the base over there, and this is the reaction first done by Strock. Okay, experimentally proven by Strock. We'll in a moment we'll see the difference or see the more exotic example of this category. So what we have seen right now, alpha abstraction and alpha elimination are similar. Both of them are giving the exactly same compound, so to speak, the carbene compound, but mechanistically they are different. There is a very subtle difference between these two. In the alpha abstraction case, the metal alkyl intermediate, that alkyl can be the base itself and can abstract the hydride, alpha hydride directly without passing through a metal hydride intermediate. Whereas for alpha elimination, we have seen there is inevitable formation of a metal hydride intermediate. But once again, both of them are forming or giving the exactly same compound, that is the metal carbene intermediate. Let's try to take an example. We have previously seen the many examples of alpha elimination. Now let's try to look at closely one of the real life example of this alpha abstraction reaction. So this is an example by Strock, and we'll discuss briefly about it. It's a tantalum complex. Let's try to look at this complex. Now we have this tantalum at the center, and we do see one alkyl group, two alkyl group, 3 and 4. Most interestingly, you see there are at every alpha carbon center there is a hydrogen atom available, but at the beta center there is no CH bond available. Of course, it's a highly engineered molecule. It's an organometallic intermediate which is kind of designed, or by default it came out to be the one which will not have any beta hydrogen. So only hydrogen, only hydride present over there is the alpha hydride. Okay. Now if you try to look at it very carefully, the product we are going to get from this reaction is going to be it is going to be a carbene intermediate, where this tantalum intermediate undergo further reaction to give you the product. Okay. So what we have seen over here is very simply this whole moiety is undergoing abstraction, and giving you the carbene moiety. So of course the other product in this case you are going to get is this one, right? And this hydride is going to be the one over here. Of course, most important thing once again is no beta hydrogen present, right? That is no surprise. On the other hand, there could be another alternative mechanism, that is alpha elimination. Before drawing that, let's try to look at one more time carefully. There is only alpha hydrogen present, no beta hydrogen present at any of the of these alkyl group. Here one of the alkyl group is acting as a base, abstracting the hydride from another alkyl group, and this is the alpha hydride, and we are getting this carbene intermediate. Alternate mechanism involve the formation of, as you can see, one can imagine it can form this tantalum hydride and this tert-butyl intermediate, right? So everything else remains same. From a 1, 2, 3, 4, 5 member intermediate, we can technically get a 7 member intermediate, right? So this 7 member intermediate, okay, if you try to look at this, we are calling as alpha-abstraction. This should be alpha elimination. So these are both of them are leading to the same product. Of course, next step would be, as you can imagine, reductive elimination from here should give us the same product. So what we have seen so far in this example, particular example, is a tantalum complex, pentacoordinated complex having 4 different alkyl groups without any beta CH bond. We have only alpha CH bond. It can give us alpha abstraction, where one of the alkyl group can act as base to give metal carbene intermediate. On the other hand, an alpha elimination mechanism can follow, where a metal hydride species is forming. In the process, we are getting the carbene intermediate, and then alkyl and hydride reductively eliminate to give you the same product as we are getting from alpha abstraction. Now the query is, the very simple question one should ask, which one should favor? Which one is likely in this, let's say, particular case? Of course, most of the cases you see the alpha reaction, alpha abstraction or elimination type of scenario. Most of the scenario we are going to get alpha elimination reaction, but there are special cases. Of course, this is one such case where I think alpha, we'll see in a moment, alpha abstraction is likely, but alpha elimination is not going to happen. And why is that? Very simply, if you try to look at that example one more time, okay, let's try to go back and try to look at the example one more time. This is the one where we have 1, 2, 3, 4, 5, 6, 7. So this tantalum is going to be tantalum 7 plus. Now, if you do the outer electron configuration for the tantalum, you would know this is going to be 4f14, okay, 5d3 and 4s2, right. If this is the outer electron configuration, now you can see only 5 electrons, that means over here 5 plus is likely, 7 plus for tantalum is a bad, extremely bad process. So it's not going to happen. So you can say that reductive elimination should not be happening. So this process should not be happening, and therefore this product formation can only be justified. The product formation, what we see in this particular case, can only be justified by alpha abstraction. Okay. Alpha elimination, although one can draw it, but it is electronically not going to be favorable because it requires a tantalum 7 plus, which is not feasible and is unlikely, and therefore the alpha elimination and following reductive elimination, subsequent reductive elimination will not be a feasible idea. It is all the way going to be alpha abstraction, that is direct abstraction, direct mechanism, no such metal hydride formation will be happening. All right. Next, of course, we would like to discuss a little bit more on this topic, and that is the beta abstraction, which is quite related. So what now we are going to see is how beta elimination and beta abstraction differs. You have seen the difference between alpha abstraction and alpha elimination. Now we are going to see beta abstraction and beta elimination. Once again, both of them will give exactly same product, but mechanistically or in terms of electronic property wise of the metal complex, electronic properties of the metal complex, it will be different. Let's try to look at the beta abstraction there. So beta abstraction. Now, of course, this is less common. More common intermediate or more common pathway, as you have learned, is the beta elimination. So this is this process basically is a concerted process. Of course, again, just like your alpha abstraction, it is it's a concerted process which accomplishes the same overall transformation. That's what is most important to remember. This gives you exactly same transformation overall as in beta hydride elimination. Okay, so what we tried to tell you is it's exactly the same process. Okay, beta abstraction is similar process compared to your that beta elimination, but mechanistically they are going to be different. I'm sure you have remembered the beta elimination process. We have discussed quite a lot about it and with a lot of examples over there. Now we'll bring your main transformation one more time just to compare and contrast that beta elimination with beta abstraction. Okay, let's first try to look at the beta abstraction reaction. So what we are going to get in this case of beta abstraction simply is this is acting as a base, so it will directly abstract the beta hydrogen, and overall we are going to get, let's say, this intermediate and RH. If this one was undergoing, let's say, beta elimination, then we will get metal hydride intermediate along with, let's say, R, and then olefin intermediate formation. Subsequent reductive elimination should give you this intermediate. So as you see, it's exactly similar. For beta abstraction, you do not have any metal hydride intermediate involved. It's direct the base alkyl group, one of the alkyl group or one of the moiety on the metal center directly abstracting the hydride from the beta position, alpha beta beta position, and giving you RH in the process, this R and this H, without any metal hydride bond formation. Whereas in case of beta elimination, it is going to be metal hydride along with the metal alkyl intermediate present, and then these two species will undergo reductive elimination to give you the same product. So essentially what is important to understand is this is exactly the same process. As you see, the net outcome is the alkane formation along with the metal olefinic intermediate formation. So both the beta hydride elimination and beta abstraction is exactly giving the same compound. Now one must remember this process differs very little, but then there are situations where only, for example, beta abstraction is favorable. Once again, beta elimination is the most preferred pathway, and most often, let's say 99% cases or 95% cases, you are going to get the beta elimination. But then there are situations where beta abstraction is the only pathway because beta elimination can be ruled out, okay, or is unlikely to be happening. Okay. So, for example, if you look at if this intermediate is 18 electron species, now this for this to happen is 20 electron species, right. So, this perhaps will not happen if you are starting with an 18 electron species like this, and then this is not going to happen. Therefore, if you are getting this product, this is likely that you are going to get through or go through a beta abstraction intermediate. Okay. Now, of course, to prove which one is likely or which one is happening, particularly whether it is a elimination versus abstraction, it is not an easy experiment to do. It requires extremely good, extremely efficient synthetic design. It requires beautiful design of the organometallic intermediate so that beta abstraction is the only preferred pathway and beta elimination is disfavored completely. Okay. There are very few examples that exist of this category, but the first one we will discuss, which is a classic in its own right. This is a zirconium complex. And Sp2 zirconium complex along with the methyl group. Okay. Now you see this is alpha hydrogen is not present, this is the beta hydrogen, so beta hydrogen is present. Of course, the product you are going to get, let's say by beta abstraction, as you can imagine the product formation, you can go about these two groups and CH4 can go out, and therefore what you have is Sp2 zirconium and this benzene intermediate, right. So, this is benzene complex, this is benzene complex. Now, most importantly, one could think of course, that this zirconium should give you this intermediate, okay, and where this benzene can coordinate with this overall to give you finally from there on we can get the reductive elimination in the form of methane. So, this is going to be your first step, and then subsequently methane elimination. Overall, you should get a Sp2 zirconium and this intermediate, which should then give you the final product, which is nothing but these two products are exactly same. Now, if you look at this is the one we are talking about is beta elimination reaction. Okay, this is the one which is the beta elimination reaction. Now, if you look at this process, okay, both we have seen beta abstraction and beta elimination. The first one, the first arrow we were trying to draw is the beta abstraction, where direct methane formation was going on. There is no metal hydride intermediate involved in this case. In the other pathway, we have beta elimination, where we have seen the metal hydride intermediate is forming, and subsequently a reductive elimination is happening to give you the exactly same compound. Now, the major query in this case, the major thing one should look at for this case is beta elimination likely. If beta elimination is not likely to happen and the product formation is still there, therefore, there is only one way to explain this observation, and that is beta abstraction. Okay, let's try to go back one more time with this example, where we do see that this zirconium, now if you look at this zirconium is a D0 center, okay, zirconium 4 plus, zirconium is 4 plus, that is D0 center. Now, as you know, this for this metal hydride formation, you should have the D electron available to undergo such intermediate, right. So, this process is not likely to be happening, okay, at the center, when you have a D0 metal present. Since it's a D0 present, D0 metal center, having a metal hydride bond formation is not going to be feasible, and therefore what we can say in this case, particular case, this is a classic example of this beta abstraction reaction, not beta elimination. It's a D0 metal center, therefore further metal hydride intermediate formation is not going to happen, and therefore we are going to get only beta abstraction. This is a paper which is a classic in its own rights. This is a science paper by Steve Buchwald's group in 1993 to 61 1696. Okay. So in this class, what we have seen so far is it's a very subtle difference between alpha abstraction and alpha elimination. Similarly, very subtle difference between beta abstraction and beta elimination. Of course, these examples are highly engineered examples. Not in every case you will see alpha abstraction or beta abstraction. Only in rare cases, but that is most important to remember and understand, and therefore knowing that beta abstraction and alpha abstractions are possible is one of the most important thing in this field, that although alpha elimination and beta elimination is likely or more often happen, but alpha abstraction and beta abstraction one should not and must not rule out. Therefore, one must be extremely careful before commenting on whether this is an abstraction or elimination. One must count the electron and judge the scenario, and therefore they must proceed with the formation of the product by a particular mechanism. Of course, it's always very difficult to prove a mechanism, but if we know the fundamentals of different pathway, I think we can have some educated guess about the mechanism supported with some experimental evidences. Okay, in the next class, we will be mainly discussing the four-centered reaction mechanism. So we have seen so far different pathways for product formation. There are different few other pathways for fundamental pathways for product formation. In the next class, we will see four-centered reaction mechanism, or so-called sigma bond metathesis. We will also see 2+2 reactions. Okay, so-called those are very famous Nobel Prize winning reactions. So we will see both sigma bond metathesis and 2+2 reactions in the next class. Well, till then, all of you keep reading and make sure that you understand the subtle difference between these processes. These are fundamentals of organometallic chemistry, and one should have a strong grasp of these principles before they want to write down any mechanism. And very simply, once one can digest, one can feel this mechanism very efficiently, writing organometallic intermediate is or organometallic mechanism is not a big deal at all. One should, but therefore one should not really take it easy on the fundamental understanding. One should be very careful and very simple in understanding what is going on. With that, for the next class, we will discuss the four-centered mechanism as well as your 2+2 reactions. Okay, till then, see you later. Bye bye.